So right, let's look at my electrolytic cell. I've got my two platinum inert cathodes and anode. And let's say I've got NaCl aqueous, right? Yep, electrolytic cell. Because even in industry we have to do electrolytic cells, so that's why. And it's a. If you haven't because you have to revisit galvanic cells as well for production, so it still makes sense. And now let's look at this. And again, that's the thing. That's why I like the previous method, because it works the same for my electrolytic cells. So it's my anode, my cathode, right? I know my anode oxidation is happening, loss of electrons, and my cathode reduction is happening, gain of electrons. Yep, same deal. Now look at all my species that I have in my thing being electrolyte. I have Na+, Cl-, and I have H2O. Yep?
Yeah.
Now look at my anode. What is going to be oxidized? What is going to lose electrons? Na+ is not going to be Na2+. It's not going to lose any more electrons. So I only have to deal with Cl- and H2O at my anode. Make sense?
Yeah.
So I look at my anode. So what's my equation for Cl-? So it's loss of electrons. It will be Cl- 2 half Cl2 gas plus an electron. Yep. How much energy does that take me?
Negative 1.36.
Negative 1.36 volts. What else do I have? I have H2O because I disregarded my Na+, right? My H2O. What is my equation for losing electrons of H2O?
H2O becomes half O2 plus 2.
Yeah, exactly.
H plus.
This is the thing, right? People before that ask like, which water equation do I use? The thing is, you have to know what do I have in my solution. So people say, oh, how come I can't have, my one H, which is the one above? Why isn't it 0.83 volts, right? That doesn't work because first that's H2O plus electrons to half H2 plus OH minus. Clearly that's reduction of water. And then it's like, oh, that's reduction of water, why can't it go the other way, it'll be oxidation. That's the oxidation of half H2 and a hydroxide. So it's not going to be that reaction, if you get what I mean, because I don't have hydrogen gas and hydroxide, if you get what I mean. So that means I have to go to the one bottom, that's the one Eric said. H2O becomes half O2 plus 2H plus 2 electrons. Because clearly that is the oxidation of water, right? So water becomes half O2 gas plus 2H plus 2 electrons. Yep. What's my voltage for that?
Negative 1.25.
Negative 1.23 volts. So which one's going to happen?
Water.
My water, because it takes less energy than this one. Yep, makes sense? Sweet. Now let's go to my cathode reduction. My Cl- is not going to be Cl2-, so I can disregard that. I have Na+, right, I've ticked this one. Na+, what's my equation? Na+, plus an electron becomes Na solid. So what voltage does that take me? How much energy does that take me?
Minus 2.71.
Minus 2.71 volts. I also have H2O again. H2O plus E minus. What does that become?
H2
Half H2
plus OH minus.
gas plus OH minus. How much energy does that take me?
Negative 0.83.
Negative 0.83. Which one's going to happen?
The H2O.
Which one's going to happen?
H2O.
Water? Water takes less energy than my Na+. Na+ really wants to be Na+. It does not want to be Na solid. That's why Na solid is so reactive. My H2O is happier to be half H2 and an OH minus. It's happier to be reduced than my Na solid. So this is going to happen at my cathode. Make sense? Now I want to find how much energy do I need to put into this electrolytic cell for this reaction to take place, right? At my anode, I just did this, negative 1.23 volts. At my cathode, negative 0.83 volts. What is the voltage I need to put into this electrolytic cell?
Minus 2.06.
Negative 2.06 volts. Does that make sense? It's the exact That's why you think about it. It's the exact same process of galvanic cell, isn't it?
Yeah.
You look at my anode, I look at my cathode, what is being oxidized, what is being reduced. I lay everything out, what is going to be oxidized based on which one takes me less energy to happen. And that's actually the same with electrolytic or galvanic. It's just that they both require me to put in energy. Does that make sense? Mm-hmm.
Who does shipwrecks here? Is there or is it just me?
Yeah.
Okay.
Industrial.
Do you know the concentration thing? Back to chlorine and water.
We do that in industrial as well.
Oh really?
Yeah.
Concentration
Industrial.
affects water.
Yeah, and they also do electrolytic cells, so that's why I've got it for everyone.
Okay.
Yep, too easy.
So when you're doing the electrolytic cell, you just look at whatever solution the two metals are in,
Exactly.
and of the salts, you look at whichever one is more likely to react based on the voltage.
What do you mean?
The voltage on the standard.
Yeah, exactly. You look at my potentials and I see which one is going to happen once more to be. If this one takes more energy to happen, this one is going to happen in preference to that one. Does that make sense?
Yeah.
So for doing shipwrecks, it's the same process with sacrificial anode when you've got like zinc attached, right? Because it wants to be oxidized in preference, so the other one's going to be protected.
The only exception is for NaCl. If the NaCl concentration is high enough, the Cl will oxidize preferentially over the water.
Or it will oxidize alongside.
Because if you look at it, right, these two voltages aren't that far apart. So if I have heaps of Cl minus and not that much H2O, I can get this to happen instead of that. But what I have down here, right, the difference is huge. The difference in energies, even if I have lots of Na+, this is still going to happen instead. I'm not going to get Na+ if it's aqueous. Does that make sense?
Yeah.
Too easy.
Okay, guys, can I ask again?
Yep.
How do you decide which water equation to use?
You look at what you've actually got. First, I have to say, is it being oxidized and being reduced, right? Let's just say, look at this, I've got water being reduced. So look at your table of equations. What is water gaining an electron?
This one, right? There's this one.
Yeah. And there's this
And
one.
what? No, there's no water there. There's oxygen and which one can we use? On that side.
Exactly. That's what I was saying before, right?
But this one is not used for liquid or grenade. This is only for rusting.
With the O2 one, we're not pumping oxygen in. So oxygen is not going to be a factor in my reaction. So you literally look at what do I have as my reagent.
Okay.
I don't have hydrogen gas and OH. No, I don't have half O2 and 2H plus and 2E minus going to H2O. I have H2O gaining an electron. That's how I know what's going to happen. Make sense? Yeah. Yeah, Anton, what were you going to say?
Could you do a 5 or a 7 mark question? Like, you do it and just explain to us your thought process whilst it's in question. That would be pretty good.
So does everyone get the redox process of galvanic cell?
Yeah, just typically out of those two, the higher number is chosen from
You choose the one that takes the least energy to happen. Or that wants to happen.
It's always the high
Oh,
number.
the high number.
It's always the high number. The more
If
positive number.
The more positive number.
Yeah.
If I have one that gives me 2 volts, one that gives me 1 volt,
Yeah.
clearly the 2 volt one wants to happen more.
Yeah.
If I have one that's negative 1 volt and one that's negative 2 volts,
Yeah.
clearly the negative 2 volt doesn't want to happen more than the negative 1.
And
You get what I mean?
you leave the signs as they are.
Of course.
Yeah. Yeah.
That's what I mean. You figure out what is happening for that actual equation.
Yeah.
Sweet. Alright, for the long response question, we've got one for all the modules, so which one would you like to have done?
Could you do production?
Look at the long response, they'll be the ones at the front of the booklet, so just have a look.
Yeah, someone else can choose one.
Yep.
CFC.
What?
Someone choose one.
Okay.